Okay, this is our third video. This time we're going to talk about the second method we're going to use to solve larger systems. Okay, it's called the matrix method. All right, here. So this time, here we're just given the system, right? So here's a system of equations that we might get. We're going to turn this into three matrices. A is the matrix of the coefficients, all right? So what that means is A equals, and it's just going to be the coefficients of the variables. So it's 1, 2, 3, 3, 4, 9, 5, 6, 7 in this case, all right? So there's matrix A. X is the matrix of the variables. Well, the variables are X, Y, and Z. So that means X equals, like this, it's just one column down, like that. And B is the matrix of the constants. So that's the values on the other side of the equal sign over here. So B it's the same format, if you will, as X. It's a single column, but it has the constants on the other side of the equal signs, right? So the first step then is you get a system like this one, and you turn it into these three equations. Okay? And then in matrix notation, it's kind of shorthand. You could write this whole system like that, AX equals B. Okay? Now, the matrix X has the variables in it, so our goal is to solve for X. Now, if A was a number, we just divide both sides by A, right? Like if you look at this equation, AX equals B, divide both sides by A. However, we can't divide by a matrix, unfortunately. We just can't divide by a matrix. What we can do is a lot like it. What we can do is multiply by its inverse if it has an inverse. Okay? So this is the one drawback to this method. If the original system of equations is independent, then A does have an inverse, and our calculator will find it for us. However, if it is not independent, right, if it's dependent, A is not going to have an inverse. Okay? So this method does not work on dependent systems, right? That's what it says here. The weakness of this method is it does not work on dependent systems like the Gauss-Jordan method does. All right. Now, doing it by hand, finding the inverse of a 3 by 3 matrix is kind of a big job, but on your calculator it's very short and sweet. So to find the inverse of a matrix, we're just going to use this X inverse key on our calculators. Okay? For example, to get A inverse, which is the inverse of the matrix A, we do the following on our calculator. Unfortunately, by the way, it's a little bit weird to write this out. The second function on the X inverse key is the matrix key. So when I want to access the matrices, I do second X inverse. Yeah, the X minus 1 key there is the X inverse. And when I want to take the inverse, then I just hit the X minus 1 key. So you've got to kind of pay attention carefully here. So first we're going to hit second X inverse. That's going to get us into the matrix section. Then you hit enter. This will select the matrix A, okay? If you want a different matrix, you can just select it with the down arrow or by typing the number next to the matrix. Then you hit the X inverse key, okay? And that actually, what that puts on your screen is this right here. It'll say A, and then with a -1 in the exponent position, that is A inverse. This is your calculator symbol for the inverse of the matrix A. All right. So if we go back to the matrix equation, remember we're trying to solve for X. We can work our way through it. But the bottom line is this, what we get is this. X equals A inverse B. So on our calculator to solve for X, what we have to enter is A inverse B. Okay? Now, at the end of this video, or actually next after this video, there's a video I pulled off of YouTube, I believe it was, that has nice shots of the calculator itself, and it will show you how to go through this process. I'm just kind of trying to run you through the basics here. So to start off again, so to do this now, after you've got matrix A and matrix B into the calculator, you'd hit second, and then the x minus 1 or the x inverse key. Okay, this is going to pick the matrix option, the matrix function. If you hit enter, this will select matrix A. You hit the x inverse key again. This puts that little minus 1 up in the exponent spot on the A, so it tells the matrix take the inverse of matrix A. Then second x inverse again, that puts us up into the matrix thing, and you can type the number 2. This will select matrix B. If you don't want to type the 2, you'll see on the screen you can do down arrow and enter. That'll also select matrix B. All right. If you do that, at this point, okay, so enter. So right now, what it should say on your calculator is this right here. Right, A inverse B. Okay, hit enter one more time, and it will evaluate that. Okay, and what it's going to say is this right here. It'll list the numbers. Now, it won't have the variables here. It's just going to list the numbers here we have in this column. All right. Now the reason it's going to list those numbers is because I'm assuming you've got the A and B in there from this original system. All right. And this is the way this original system comes down to. These are the solution. It gives you these three numbers. Now this time the numbers work out nice and clean as decimals. You could keep them, but sometimes they'll be non-ending decimals or something, and you might want to turn it into a fraction, into fractions. So if you want fractions, leaving this on your screen, don't do anything else, hit the math key and then hit enter, right? Math and then enter. This will select the frac option, and then enter again. It tells it to convert these numbers here, right? These numbers up here into fractions. And in this case, what it does is it gives you minus 7/8, 3/4, and 9/8. And those are the values for x, y, and z respectively. All right. So that is the way that works. So next on our list, you'll see a link for a video that runs through this with screenshots. All right, to tell you how to do this matrix method, and they'll also run through a quick version of doing the XREF and run over that pretty quickly again too, using the RRF method as well.